Hello, this is Dr. Mears, and today we are going to be modeling periodic functions. Periodic occurrences happen in repeated cycles. Knowing this, we can make predictions based upon the cycle. Let's look at an example. Ben is a fisherman with a boat in Rawl Harbor. This is part of a graph of the depth of the water at the mouth of the harbor. So we're going to be looking at the depth of the water in meters over a period of time. That time are the number of hours after midnight. So if we look at the number of hours after midnight, there are none at 0 hours after midnight. The depth is about 3. 2 hours after midnight is 2 a.m. 4 hours after midnight is 4 a.m. 6 a.m. and so on. So at about 4 a.m., we can see that the depth of the water is at its max height of 8. This cycle will not go over a max height of 8. Now, if we're not understanding hours after midnight, here we have, I'm just going to complete this, 8 a.m., 10 a.m., then we have 12 p.m., and then this is 2 p.m., that's 1400 hours. 6 is 4 p.m., that was 16, 4 p.m. 18 is 6 p.m., 20 is 8 p.m., 22 is 10 p.m., and 24 is 12 a.m., and we start back at 0. And so this is military time when we do hours after midnight. And so if you weren't understanding what does the 16 and 18 mean, you can pause the video and just fill in those hours that we're used to when we do a 12-hour day. So I am going to be using the military time, the hours after midnight, because that is what the problem is stating. But I just wanted to bring a little bit of familiarity to this problem for you. All right, so let's go through and dissect this graph. The first thing that we have to do is find the amplitude. All right, remember, amplitude is where we take the max height, we subtract the minimum height, and we divide it by 2. So it's kind of like we're cutting the graph in half, and then we're seeing how tall it is from that halfway point. So let's find the amplitude here. So max, we already investigated that. Our max is at 8 here. So it's going to be 8 minus, what is our minimum? I'm going to look right here. Our minimum happens at 10 a.m., but our minimum is 2. So 8 minus 2 divided by 2. So our amplitude is going to be 6 divided by 2, which is 3. Okay, so amplitude is 3. I'm just going to write that over there. All right. Let's look at the period. Now, when we look at the period of the function, we're going to need to do a couple things. 1, when we get our answer, it is going to be in pi radians. And 2, we are going to need to find how long it takes for one cycle, and that's going to be determined by the x-axis. So how long, and this is numerator and denominator here. The denominator is going to be how long it takes one cycle, and that's on the x-axis. So we have to look at the x-axis and see how long it takes for us to go all the way up, all the way down, and then back where we started. So if you notice here, we start at 3, and this is 0, so we're going to go all the way up, all the way back down, and we have to come back to where we started. So this is one cycle. Oh, yep, that is one cycle there, because we would be going back up, so we would be going up here. These two are the same. So this is one cycle. So it takes from 0 to 12, so this would be 12 down here. And now I said that we have to put it in pi radians, so what you're going to do is the numerator always is going to be 2 pi. Always, it will not change, because in a unit circle, how long does it take for one cycle? 6.28, and 6.28 is 2 pi. So it's always going to be 2 pi, so this is going to be 2 pi here. And so if we reduce this is going to be pi over 6, because 2 and 12 reduced to pi over 6. And so I'm going to actually label this as B. We're going to be using these numbers. Okay, so we have A and we have B. Okay, let's keep looking at our graph. we need to find the horizontal shift. Now, the horizontal shift is from the original graph of either a sine graph or cosine graph. So I'm going to write a couple notes before we get the horizontal shift of our graph. So if we were looking at a cosine graph, we always look at the y-axis and where it starts. So a cosine graph has a maximum at 1 on the y-axis. So if we were comparing this to a cosine graph, we would want to see, we know the max height is here, so that must have shifted over. So it's all about the max height for cosine. So how much did that shift over? So if we were looking for a cosine, what would the shift be? We know that at 0, that's where its max height is. Okay, so at 0, that's where its max height was. So it went from here at 0 and it shifted over. So how many did it shift over? It shifted over 4. So we look, how many did it shift? It shifted 4. So for cosine, the horizontal shift is going to be 4. All right. Now, what happens if this graph is an original sine graph? So sine graphs, it's the middle of the graph that is going to be shifted. So the middle of the graph here starts at 0 for sine graphs. So where would the middle of this graph be? Well, let's see. This looks like it would be to the bottom. So the middle of this graph looks like it would be about here. Actually, the middle, we know amplitude is going, that's how high it is. So I'm right. So this looks like, about here. So our shift may be about 1. So if it was a sine, our middle part would have been shifted just about over about 1. Okay, so we have to determine from the problem, do they want us looking at a cosine graph for the shift, or do they want us looking at a sine graph for the shift? And they are going to tell you, I'm actually going to reveal to you, they are going to tell you when we get down to part E, we are going to be looking at that cosine graph. So I'm just going to put a little box around that. Okay. All right, what's next? Next is our vertical shift. Our vertical shift is going to be how far from our original graph did it either go up, which this one, remember the graphs usually start down here. So how far they either went up on the graph or how far they went down on the graph. Because remember, they start where their middle is actually, down by the x-axis. So this definitely looks like it was shifted up from this x-axis where it originally crosses. It doesn't matter if it's sine or cosine, the original graph crosses the x-axis. So this graph does not cross the x-axis. It has been shifted up. And there is a nifty little formula, which kind of reminds us of amplitude. We just take the maximum, which was 8, add it to the minimum, which was 2, and divide by 2. And when we get that, we get 10 divided by 2, and that is going to be 5. So that is going to be our vertical shift. I'm just going to label this D. Our vertical shift D is 5. Okay? So why are we doing all of this? And the reason why we're doing all of this is so that we can actually make an equation. And in our problems in our book, they are going to tell you whether they want you to make a sine equation or a cosine equation. For this one, it says write down the equation of the function for the depth of the water in terms of m and h, where m equals a cosine b h minus c plus d. When they say in terms of m and h, what's going to happen is we're still going to have an m in our problem, and we're still going to come out and have an h in our problem. We're not going to take those two variables out. I usually like to use y and x, and you're going to see that in the next problem, so don't get confused. It just means that m and h aren't going to be out of this equation. They're going to stay there. So let's fill in what we have, okay? Because we have everything. Now it's just filling it in. So m equals, that does not come out, a This is our A. This is our small a. Our little a is 3. So let's fill it in. 3. We're going to write down cosine. Okay. Parentheses, B. B is our period. So this is actually B right here. Remember, I wrote down this is little b, pi over 6. Okay, parentheses. Our H stays. It does not move. Minus. Now our C. Our C is our horizontal shift. This is C right here. C equals 4. I'm going to put a little box around it because we're not doing the sine graph. They want us to do the cosine. So for our cosine, our horizontal shift, that is C. If you notice, everybody, notice how this is labeled A, B, B, C, C. Guess what? D, D. Correct. Okay, so let's put in C. Be careful because this is minus, and then I'm going to put a 4. Close my parentheses, plus D, plus, and D is a positive 5. So we now have our equation. This is our equation for this graph. So if I wanted to do this in my calculator, I could put in my calculator, and guess what my calculator is going to give me? You're right, this graph right here. Okay, so we used a graph. We found 4 components. We were able to write a formula. Let's do this one more time with one more graph, and then perhaps answer some questions about it. Okay, next. Oh, we're not done yet. We're actually going to be using it. Okay, so we need to calculate the depth of the water at 9:30 a.m. All right, so I thought we were on to problem 2, but we're not. All right, so calculate the depth at 9:30. So first, let's just look at our graph. So at 9:30, and is that a.m., everybody? A.m., perfect, okay. So let's look at 9:30. So 9:30 is between 8 and 10 here. So I'm thinking 9:30 is going to be about here. So we would look up, see on our graph where that point is, and then go all the way over. Now this is tough because it looks like it would be about 2 meters. So using the graph, I just went to 9:30 a.m. all the way up until I touched my curve, and I found that the depth would be about 2 meters, okay? So graphically, I found about 2 meters, okay. Algebraically, let's just do algebra. It's a little bit early in the morning. Let's do the algebra way. Algebraically. Spell that for me. Leave it in comments. I know how to spell it, but I'm a little tired today. Okay, so using algebra, let's write down our formula that we have here. M equals 3 cosine pi over 6 times, now we have H. H is going to be height. That is H. H is height. This is height. And M is depth, because remember, depth is in meters. And so, not height. My bad, you guys. I'm sorry. I'm still thinking about how to spell algebraically. This is hours. H for hours. M for meters. Okay. So, H is for hours. So, here they give us the hour after. They give us 9:30. So, we're not writing 9:30, everybody. We're writing 9.5. Because we're not, remember, this is the number of hours after midnight. This is not, regular 9:30 a.m. 9:30 is 9.5 hours after. So H equals 9.5. That is 9:30 a.m. transferred to a decimal. Okay, so that's the hours. Then we have minus 4 plus 5. And what we could do, just put it in your calculator. So I'm going to take my calculator out. Here we go. On. Now, be careful. We're in radians. So, mode. Be careful. We got to mode. And make sure we're in radians before we do anything. All right, mode. I am in radians. Excellent. To get out, remember it's second mode. We quit. All right, let's just put it as you see it. 3 cosine. Now this pi over 6, yes, you know me. I'm going to put this in double parentheses here because I like keeping my fractions together. I like to hug my fractions with a parentheses. So I'm just going to do parentheses pi over 6 here. So that's why I have the double ones. And then I'm going to open up my parentheses, 9.5 minus 4. And I'm going to close them again. And now here's the thing. This has a set of parentheses, so now I just have to close everything. So it just kind of looks like this, where I'm just closing my parentheses. You have to make sure this 5 has to be outside of these original parentheses, or you're going to get the wrong answer. So it has to be outside of the parentheses. All right, plus 5, 2.10. Hey, very close. So 2.10, very close with what I got on the graph. So the number of meters is 2.10 meters. So at 9:30 a.m., the depth will be 2.10 meters. And I'm just going to those 3 significant figures. Yay, pretty neat. All right, Ben's boat can only get in and out of the harbor. When there's at least 4 meters of water at the mouth of the harbor. This is true. This really does happen because of high tide and low tide, everybody, that you are able to bring your boats in only at a certain time. People actually have gotten stuck because they can't get back in because the water's too shallow. And Ben sleeps until 10. This reminds me of one of my friends. Ben actually sleeps till 10 a.m. Okay, so we need to use our graphical display calculator to find the next time that he can go fishing. We're going to be exploring the window feature. All right, so graphical display calculator. So here what they want us to do. So we have at least 4 meters. So we're going to have our original equation. And I'm going to put in an x here. I like using x and y so much better. And what they want us to do is they want us to see when these are equal, because we need to find when he can go fishing. So when these are equal, these 2 equations, that means that he's able to leave the harbor because there'll be at least 4 meters, so 4 meters or more. So if it's greater than that's great, but we at least need these 2 to be equal so that he can leave the harbor because there needs to be 4 or more meters left. All right, so what do I mean by let's explore the window and everything? First, let's get this in our graphing calculator. So if you push y equals, let's put it in just as we did when we were solving. I am going to use those double parentheses, and if you need to pause the video, that's fine to understand how I'm using parentheses. Remember, this is the X button right here. And remember, please close these parentheses. The graph is not going to be correct if you didn't close these. You need the 5 on the outside. The plus 5 needs to be on the outside. Enter, and I'm going to do the number 4. Again, we put these 2 in. We need these 2 to be equal because once they're equal, we know there's at least 4 meters and he'll be able to get his boat out. And also, you make sure the mode, make sure you are set to radians because it won't work. So just a couple things to check. Okay, so usually we press the zoom key, but we're not going to press that today because we're going to be using the window key instead so we can actually see the picture of the graph. So we're going to push window. And here's where really understanding the problem comes in. Our x values, if you notice on our graph, here's our x-axis. Where do they range? Our x values range from 0 all the way over to 24. So we have a minimum of 0 and a maximum of 24. So when you press this window key right here, it says X minimum. So we start at 0 hours and then we go to an X max of 24. So you can press 0 and then you just press enter, 24, press enter. Mine are already preset. I'm just going to go on a scale of 1. That just means I count by ones. Now let's look at our y-axis. So our y-axis also starts at 0. That's the minimum. And what's the maximum of the graph? It's 8. You could go to 9 if you want to, but it'll still show you the correct picture. So our minimum is 0 and our maximum is 8. So we put those in, minimum of 0, max of 8, and a y-scale is 1. Don't need to worry about these. All we're doing is just setting up our minimum and our maximum. Now what we can do, and if you want to write this on your paper, x min is 0, x max is 24, x scale, that's what we count by, is 1, y min is 0, y max is 8, and y scale is 1. So just so that you remember, it's all just from the actual problem from the graph, okay? All right, let's push the graph. Yay! Okay, so this is the picture that was given to us before. If you press this key, it's called trace right here. Press the trace key, we can see on the bottom, X is 12. So that means 12 p.m. If we move it to the right, to the left, I'm just going to push this little left button, we can see. So our time is adjusting, 11 hours, 10 a.m., 10:30 is about 10:5. So we know, when does Ben wake up? So does Ben wake up at 9? No. So Ben wakes up after 10. So here's 10 o'clock. Why is the depth of the water? Okay, at 10, what is the depth of the water? The depth is 2 meters. Can he get out? No. He needs at least 4. So he can't get out. He can't go yet. Okay. So he woke up at 10. Let's keep going. Let's keep going to the right. 11. Now at 12 p.m., the depth is 3.5. Can he go yet? No, he can't go yet. He has to wait till it's 4. So that's where this red line comes in handy. This red line is our y equals 4. So where they cross, that is their equilibrium point. That is their point where they're equal. That is the intersection. So I'm thinking it's probably about, now this is an estimate right here. It's probably about, here it's 4.01. So I'm looking at about 12.4 hours. So just by estimating from the graph, so at 12.4 hours, he can go. Okay. Let's say that we want a perfect estimate. You've learned this in other videos. What we can use to get a precise estimate is we can use the second trace button. So if we press second and then we press trace, we're going to see this intersection. We can go down to the intersect button. It asks you for the first curve. Now don't press enter yet, because we want to get that point right there. So the first curve, I'm just going to go to the blue curve. I'm just going to go down here. This is just on one side of I want this point, so I'm just going a little below it. Okay. Now the second curve, I want this point. So what I'm going to do is put my little blinky dot over here, because I want where they cross. So I want on one side of where they cross and on the other. Press enter, and then it says take a guess, and yep. Ooh, look at that, 12.35. So I did second trace, and then I pressed enter a few times, making sure I was on both sides of intersection. Okay, and I got at 12.4. It's actually 12.35, as you can see right here, 12.35, which is really good. That's great. So estimating, not having to go through all of this, I got 12.4 just by looking at it. And going through the precise steps, I also got at 12.4 hours. And this is, remember, this is hours after midnight. Okay, so this has been a long one. This has been a long video. So what I'm going to do is I'm going to stop the video here, and I'm actually going to make a part 2. And part 2, I am going to be doing this second question, and I will label it as part 2 of modeling periodic functions. And I will make that in one moment, but I do want you to have a break because that was a lot of math right there. I hope it helped, and come back for part 2.